This is Chem 110 or a similar course, and this is segment 15 where I'm going to start talking about mole ratios. In the last segment, I introduced the idea of why any of this matters by using the term stoichiometry. So if you Google this or you look in the index of your book, look under stoichiometry and you will see something similar. So I introduced a recipe where the ingredients and the products we can relate via ratios. So I started with my brownie analogy because most people most of the time are familiar with that. Okay, then I moved ahead and said, okay, well, the numbers in front we can also describe as moles, and we can have mole ratios. So I went through a couple of examples with you. And now we're on the next segment. How are we going to use those mole ratios? Well, again, remember, if we have mole of A over mole of B, then we can convert mole to mole using the mole ratio, just like we did before. So you should by now be having a collection of your conversion factors, like a tools in a toolbox. I'm going to use my stapler for one kind of job, and my calculator for another kind of job, and my pen for another kind of job. I'm not going to staple my pages together with a pen. You choose the right task for the job, okay? So let's see if we can try this. How many moles of water can be produced from the complete combustion of 3.30 moles of methane, which is CH4, assuming oxygen gas is in excess? Okay, so it's important that we recognize that I could run out of oxygen, but I'm not going to worry about it, just like I don't have to worry about breathing in and breathing out when I'm talking to you about how to do your chemistry. So the process is still going to be the same. I'm going to have my starting place, 3.30 moles of CH4 over 1. Remember, the 1 in the denominator is a placeholder. That does not limit your significant figures. Over here, my ending place is moles of water. So then I need to ask myself, how am I going to get from mole of one thing to mole of another, mole of A to mole of B? Well, I'm going to use the mole ratio, and I'm going to get the mole ratio from my balanced equation. Okay, so factor label method says that mole CH4 goes on the bottom, mole H2O in the numerator, and then I look at my recipe. My recipe or my reaction says 2 moles of water, so the 2 in the numerator, 1 mole of methane, 1 in the denominator. Moles of CH4 cancel, and moles of water is the unit, and now we just do the math, which is 6.60. By the way, the mole ratio is also not a measured conversion factor. This is what is measured, not this. So 3 sig figs, 3 sig figs. Okay? Same thing, 5.00 moles CH4, moles of O2. Okay, so this time I'm not going to just say I have excess. I want to know how many moles do I have to put in there. So again, mole CH4, mole O2. We look at our ratio up here, 1 and 2. Okay, mole CH4 cancels, and we end up with 10 to 3 significant figures. Okay, now all of this is great and well and good and all, but in real life, you don't have a mole unit on your balance. You can't pour out a mole. You can't just weigh a mole. What you have to do is you have to put it into a unit that's useful. Okay, so for the moment, we're going to have grams. Okay, So same thing, 12.0 grams CH4 over 1. We're looking for grams of CO2. Okay, that's my phone in the background, and I'm just going to ignore it. Okay, now gram doesn't lead us to this. This only tells us mole. So we have to know how to go from mole of A to gram of A or back again. And in order to do that, you need molar mass, which means you're going to need your periodic table. Okay, so you should have your periodic table handy because you're going to need the molar mass of this, and you're going to need the molar mass of this. Okay, now for the sake of the video, I'm going to sprint past how to add that up. If you don't know, you need to stop, pause, and practice that before you move on. Okay, gram CH4, mole CH4. So here's where my molar mass is going to come in, 16.0, and notice we're in mole. Now that I'm in mole of A, I have to get to mole of B. I have to go through the mole ratio. So I'm going to have 1 mole CH4, 1 mole CO2, and then our moles are going to cancel, and then I'm going to squeeze in here my molar mass, which is 44.0 grams of CO2, 1 mole CO2. So notice I have the unit and the substance that I'm looking for. That's why you always have your starting place, ending place, and then fit in your conversions. Okay, so now what you see is I'm going to take 12.0 times 44. And then I'm going to divide by 16. Remember, as far as my calculator is concerned, it doesn't care about the trailing zero. So I get 33, and I have to put the trailing zero there because I have 3 sig figs. So I'm going to check my work again. 12 times 44 divided by 16. 33, and I have to put in the trailing zero. Okay, if I want, depends on my calculator. A lot of these calculators have a fix button, but this one doesn't. So sorry, I can't change it. Okay, so I'm going to do one more. 44.5 grams CO2, grams of H2O. Starting place, ending place. Starting place, ending place. Okay, so my plan has to be gram CO2 to mole CO2 to mole of water to grams of water. Okay, this is what I did up here. I just didn't write it down. Okay, and it's the same thing of me telling you the conversion factors. Okay, so if I started with molecules or atoms, I wouldn't want molar mass. I would want Avogadro's number. So in other words, you have to let yourself think through what tool you're going to need for the job. And that's where the time and practice comes in. Okay, so gram CO2, mole CO2, so I need molar mass. Okay, again, I'm not stopping the video to add these up, so you'll need to do that yourself if you don't remember how to do it. Okay. Mole CO2, mole H2O. Here's our mole ratio. So I come up here, 1 to 2. And then moles to grams, or moles to grams. And again, get out your periodic table. I'm not going to stop the video, but 18.0 grams of H2O, 1 mole H2O. Okay, gram of H2O is the unit I have. Grams of H2O is what I'm looking for. Okay, so I'm going to get out my calculator. 44.5 divided by 44 times 2 times 18. The trailing zero is there, 36.4. Okay, so I'm going to try again. 44.5, 44 times 2 times 18. Oh, okay, now I get something different. So I'm going to try again. Sometimes we have to just try a couple times. It's the way it goes, especially when the phone rings. $36.4. Okay, so I'm going to stop this segment here, and then I'll do one more with you, and then it'll be time to practice on your own.